Hello my 3D printing multi-material fanatic friends. Today we're going to do the physical calibration of the ERCF. This is going to be a longer video and we're going to cover a lot of topics. We're going to cover the selector offsets, we're going to cover the servo arm positions, we're going to cover the gear stepper calibration, we're going to cover the encoder calibration, the Bowden length calibration, and the individual gate rotation distances. These are all the physical aspects of the ERCF which must be calibrated before we can attempt multi-material printing. It is a lot to cover, so hang on. Also, the point of this video series is to show you how to make an ERCF and set it up successfully. With that being said, I have included a lot of mistakes in this footage instead of editing them out, and I've also included how I go about fixing them to kind of give you an idea how it flows for me when I'm diagnosing a system and getting it set up. I did, however, edit out a lot of invective and obscene language in the interest of national security. So I'll stop with the overuse of convoluted, bewildering, and resplendent rhetoric and commence to bestowing some knowledge. Alright guys, welcome back. We're going to start working on our physical calibration of the ERCF. So we're going to go to the Hare Wiki. You can see the address here and I'll put it in the description. And we're going to go over here to number 4, calibration. We're going to click on the top header there, and we're going to go through this step by step. There's some reading here you can do. Basically, it tells you there's a flow of how things need to kind of work. In example, in order to calibrate the Bowden, we need to know what the encoder is doing. In order to know what the encoder is doing and calibrate it, we've got to calibrate the gear. In order to calibrate the gear, we've got to be able to squeeze filament, so we have to calibrate the servo. And to calibrate the selector gates is kind of on its own path because it doesn't rely on any of these others. And then when we calibrate the Bowden, then we can calibrate all the other gates. So the first step is to calibrate the selector offsets. Now, this is pretty automated. If you've done a really good job at printing all your parts on the ERCF and all your gates are perfectly matched up in width with the CAD, this will turn out perfect. Most of the time it doesn't because nobody's perfect. But what we can do is we can copy this, go to our console, and paste, and then send it. So it's going to home the selector, it's going to move clear to the other side, and it's going to come back and home. It measures the entire distance over all the gates, and then it calculates based on the CAD dimension what the gate should be. That's great in a perfect world, but typically errors build up. Print like your Z height when you're printing, how much squish you've got and all that makes that, maybe you don't have a perfect 22 millimeter width filament block. Maybe it's 19 and a half, maybe it's 22 and a half, maybe one or two of them are 22.7 or something like that. And as you stack these things up while you're building your ERCF, the width gets longer and longer, and you have a stacked up of tolerances. If say we've got this gate is 0.5 too big, this gate's 0.7, 0.5, 0.2, 0.6, and as it stacks up longer here, and we try and squeeze all these filament gates together, well, when we come here to the end in this hole, it's going to be a little bit out based on what the CAD is. So right now you can see in the output, it's calculated where each one of these gates should be based on the CAD dimension and the end stop and the end of the travel. However, as I've explained, it's probably been a good idea to go through and calibrate each gate. What you can do is take a small piece of filament like such. Notice I have a little nub of PTFE in there, kind of help it guide it in. It's kind of a pain to put it in there if you don't have that PTFE, but you're going to run this piece of filament in there, and you should see it kind of push past the encoder into the block. And if it fits, you know, we're good. We'll want to do a shut off the motors, and you can do that with mu underscore motors underscore off. That just disconnects the motors, so your selector can slide around wherever you need it to be. So we're going to take a piece of filament, slide it in there until we feel it stop. Then you can feel it go in to that first part of the filament block where it's in that hole, and just kind of center it up. And then we're going to issue the next command. And we're going to add gate equals 0 on there, and then hit the go button. And it basically goes from wherever the selector is at and hits the home stop. Now you see here, this is 3.7 millimeters as to what it originally thought was 2.1. So there's quite a difference there. Now, you do this for each one of them. I am going to issue MMU motors off, and I'm going to move it over to gate 7 because we don't necessarily need to do all of them on camera. But it's the same process. Put the filament in, get it to where it hits that hole, kind of move it around, get it about the middle, pull the piece of filament out so it doesn't jam it. Go back, and then we're going to call that gate 7. Make that measurement. See, the selector moves back, hits home, and it measures from where it was to where home is. And as you can see here, this says 164.8 millimeters as compared to 164.1. So it seems to me that maybe our original calibration on gate 1 is a little bit off. So if you see some kind of anomaly like that, you want to check it out. Here we're at 164.8 or 0.1 where it measured it originally, and now we're showing 164.8. That's 0.7 off. That's less than a millimeter. But when we get 2.1 versus 3.7, that kind of makes me think something's up, and maybe I did something wrong. And this is a good lesson, because while you're doing this, you want to get everything as close as you possibly can. We don't want to have any issues that crop up. Just like the filament blocks, as the tolerance gets out, that tolerance can stack up. The calibration, if you start with your basic calibration and then the next calibration step has more error and more error and more error, it can all stack up. So we want to get this pretty close. So I'm going to go ahead and turn the motors off, and I'm going to move the selector to gate 1. Or gate 0, excuse me. And I'm going to try this again just to see and double check that we've got everything in place. Now that's in, and I can feel it go in, and it looks like down here in the corner it's about the right place. So I'm going to just kind of double check that, make sure it slides in easy. There we go. Now I'm going to redo gate 0 and see what we come up with. Now it says 4 millimeters. So I really think that something is off here, a stack up the tolerance, whatever. Maybe I just don't have them all smushed together right. Or, you know, it's just the position of the end stop. So it measures the difference between this hole and where it touches the end stop. So if the end stop is back a little bit more, you would get one error that does not stack up as it goes out. And I believe that's probably what we got here. So you kind of have to be analytical about this and watch for what problems might crop up and take them one at a time, try and figure out what's going on. And I believe what's going on here is we're not actuating that in-stop switch in the gearbox over here. We're not actuating that as at the same place where Happy Hare thinks it should be based on calibrations over history. So on this one, we'd have to go through and calibrate each gate to account for that like 2 millimeter offset on our home switch. That's a good lesson. Calibrate each gate every time, unless you're perfect. And I'm not perfect. Anyway, I'm not going to go through all the gates because that would be boring. And I'm already boring enough. And believe me, I have a 10-year-old autistic son that lets me know that about every day. All right, so the next step we're going to go through is the servo calibration. Now, when you do the servo calibration, you don't want to put the servo arm on before you've done it. I have it on because this is like the 14th take. All right, so don't put your servo arm on before you set it up. What you do want to do is your first calibration should be, your first step should be do MMU underscore servo and then POS. And that is not POS as in the MG90 is a real POS. This is just short for position. So position equals up. That's going to put your servo in its home position, wherever that is in your config right now. And I would say on the config and then MMU parameters, you're going to have your servo angle here. Now, on different servos, left is low and some of them right is low. So here it says MG90S is 30. For the up angle, Savox is 140. And then you'll see they kind of reverse each other from 30 and then 30 here and then 140 and 140 here. So it depends on the servo. This Pro Modeler, I've done these before, and 30 is about right. So double check that your up angle matches whichever servo you have. Now, if you hit it in up angle and it tries to go the wrong way, you know you're reversed. Anyway, when you do this, you want to issue this position up first, right? That sets the position of the servo back all the way. Now, when we do this, the servo, the little flat on the arm in here, should sit against the side of the servo. And that's what we want. And then you can set the servo to your up position and then physically put the servo in that position. So you kind of got your splines lined up there. Now, the next thing we want to do is use MMU servo and then angle equals, let's try 60 and see what it does there. Now, if we look at the servo, it's not at the bottom, but it's not where we need it to be. We want, and these are thumper blocks. They're different from the triple decky. They don't have the little thing that goes up in the front. So this is going to be a 2-position setup. But this is not quite where we want it to be. So let's try, say, 90. And see where the servo ends up. Now that's looking pretty good. The servo is pushed down. It didn't try and kick back. And it's holding the gate. So I'm going to say that's probably pretty good. But let's look at, let's go back to 30. Or position up, which is at 30 because of our config. Now let's do a 120 and see what happens. Now watch that servo real close. I hope you can see it on the camera and I'm not blocking it with my fat head. But see how it goes back and then it kicks back just a little bit. We don't want that. What we want it to do is just slide right into position and stop. If it goes over and it kicks back, that means we're pushing the servo too far. We want to just slide in position and stop. So let's try position up again Okay, and let's back it down to 110, or let's go 100, and see if it still kicks back on us. Just a little bit. Let's try push it up again, and I move it clear back and then forth, because sometimes servos, on very small adjustments, you won't see it. So I move it clear out and then come back. Let's say we did 100, let's do 95. It just kicks back just ever so slightly there. So we'll try position up again, and let's go back to 90. And it still kicks back just a little tiny bit. So it might be, 85. Yeah, I'm thinking that's probably about right. It just barely kicks back. And from here you can use the grip test, which isn't part of the config, but you can check to make sure it's gripping that filament all right. If you get to where it goes up and doesn't swing back at all, then you can adjust this if you don't get enough grip. And it's going to be a balance. This thing, you want to adjust it 1/8 of a turn, maybe if that, maybe 45 degrees at a time. And just ever so slightly, because it's easy to overrun the power of the servo with this spring. So it's going to be a balance between, does the servo kick back a lot or does it grip? So you'll have to find a happy medium in there. And once you've done that, you've written down your angle, and this is going to be the MMU, the servo down. So then we'll issue MMU servo. We're going to angle equals, and we had 85 right here. So 85, then we're going to go position equals down, and save equals 1. So that is going to take the servo, save the angle at 85 degrees in the down position, and it's a save, positive save there. So now it says servo angle 85 for position down has been saved. You can kind of confirm that by coming over to your MMU folder and in mmuvars.cfg, and it should tell you in here your servo positions. So now we have down at 85, up at 30, and with the thumper blocks, up and move should be the same. In the Happy Hare calibration docs, it has really good pictures about how it should work with the triple decky. So this shows you, this is the up position. It should touch that little tab sticking up, and that releases the gate over here, the gate trap, so that the filament can move without having the gear moving it. This releases the gear and releases the trap. Now here in the move section, the trap back here is engaged, so the filament can't walk back and forth, but the servo arm's not touching at all, and the selector can move back and forth without messing with the filament hats. And then here in the down position, you see it swings over and it pushes the filament trap down, and the gate is also down, so the filament can move, but it uses the gear. That's how you calibrate your servo. Pretty simple. Follow the directions, get the positions right. You shouldn't have much problems. Make sure you don't get the servo kicking back too much. Everything will be good. So the next one is to calibrate your gear stepper. Now that we have the servo calibrated and we can pull filament, we're going to calibrate the gear stepper. This is similar to the rotation distance on your extruder and clipper. Matter of fact, it's kind of the same thing. So we're going to use these commands, tell the position down. This MMU test move is just a move. It tells Happy Hare to move the filament 100 millimeters. It doesn't care whether there's a clog or the encoder moves or anything at all. It's just saying move that gear 100 millimeters. Now, I have In the back here, I have some filament, probably 1.5 meters, 2 meters. And it's just kind of hanging there in the breeze, which is fine. As long as it doesn't get tangled up on something, it'll be okay. Which, there we go. We'll leave it like so. Has a mind of its own. And it's loaded into the gate. You run it through the, and I didn't put it through the buffer because we don't need it for that. Just run it back in through the coupler block, run it up, get it into the gate. You want it to kind of be flush with the face here, right? About there is about where a good parking position is. And we're going to use the MMU servo position down. So we're going to paste the command in our console. Hit go. That puts the servo in the down position so it grips the filament. Now, we want this filament to be right even with the end of our little stub piece of PTFE. You can kind of grab and adjust it on the little end knob there, or you can reach around back and just move the gear. Just get it even there. Get as close as you can. And then we're going to issue the move command. And this needs to be in gate 0, by the way, because gate 0 is the base config, and all the other gate distances, the extrusion or the rotation distances, are all based off of this gate and a ratio. So now we issue the command, and it's going to push out what it thinks is 100 millimeters of filament. Now, I like these things. This is a ruler from like a woodworker square that has the sliding angle that goes on there. I'm not a woodworker, so I don't know what the exact term is. But the neat thing about it is it's got a little screw that kind of clamps it down, and there's a groove in the middle. Well, that kind of helps hold the filament kind of straight along there. And if you just kind of put that filament right down in a groove and kind of push it down flat with your thumb, you can see here, and it's probably not on the camera, you can't see real well, but right there it looks like it's about 101.5. It's real close. So the next step is to go back into Happy Hare and issue the next command here. And instead of using what they've entered, we're going to say it's 100.5. I said 101.5, I think, but it's only about 0.5 millimeter over 100. So we issue that, and it's going to say, okay, the gear stepper rotation distance is calculated to 22.552, basically, and it saved that number. So now, if we issue our move command again, but we can be real sneaky and put a minus sign in there, it'll pull that filament back in. And it's probably if you had an adjustment, it's probably not going to be perfect. But here we can say, just give a little, yep, there we go. So now it's flat again. And we can issue our move command with the positive number, move it out, and then use our ruler again and lay that filament down in that groove real nice. Hold it in place, and man, that looks to be just about dead on. I'm going to call that good. Now, it's important to get this as a pretty precise measurement, because if it doesn't move 100 millimeters when you tell it to move 100 millimeters, that is one of the things that's going to stack up going down the line. It's going to cause more problems as you go forward. So make sure and get the gear calibration done correctly. So now we can move on to step 4, which is calibrate your encoder. Here you've got filament in the extruder. It's sticking out. It really doesn't matter as long as you got about 0.5 meter on the other side of the ERCF. You can issue this command, and it's going to move back and forth 3 times about 400 millimeters. So we'll put that command in, and send it to the machine, and we'll watch what happens. Now you can see it pushes filament out about 400 millimeters, and it tells you how many counts it counted. Now it pulls it back and shows you how many counts there are there. Now what we're looking for on this is some consistency. We want to see about the same number of counts all across here. We're looking like about 3 millimeters total difference from 424 to 427. That's not horrible. It's not great though. And this is another thing where the stack up of errors in your calibration can cause more and more problems down the road. So what I'm going to do is I'm just going to run that again, and we're going to see if it doesn't kind of settle in better. And it kind of gets a better count, and it knows better about what's going on. See here, now we're up to 4. So that tells me maybe something's not quite right. So now let's look at this real quick and put on our analytical mind hat. Every one of the positive counts is 428. Every one of the negative counts is 426. So it's not counting as far when it pulls in as when it pushes out. That was a real problem with the smooth encoder bearings. Before we did the ERCF V2, the encoder housing had a smooth bearing instead of the V-groove bearing. And you'd start seeing that kind of stuff because it would let the filament kind of walk up the side of the encoder gear hob in there, because it uses a BMG gear to kind of count the filament. So the V groove was made to help keep that right dead in the center of the encoder wheel hob. So this right here, what I see here, I think what we're seeing is probably a little bit of bearing error. So I might need to go into the encoder housing and adjust that just a little tiny smidge to make sure that the bottom of the BMG kind of gear hob, where it's got the serrations and the filament's supposed to ride, make sure that's lined up exactly with the V groove in the pressure bearing that rides on there. And I think if we did that, we'd be perfect. I'm not going to mess with that on this video, but if you see something that's out of whack like this, 4 millimeters isn't horrible. It could be better. I think because this is a backup ERCF, actually it's one I built for my friend, and he's letting me use it to do these videos. So thanks again, John. I appreciate it. I'm not going to mess with this on camera. I will probably get it better as I go forward. So if you see something like this, try and make it better. I'd almost say, if this is your first go around and you see it very consistent on the positive and very consistent on the negative, you could probably get away with it. Me being picky, I think I'd go after it, figure out what's going wrong. But anyway, we're going to go to the next step, which is calibrate the Bowden length. Now, here you're going to have to pull that little stub out. You're going to have to measure your Bowden tube that goes into the ERC or the printer. You're going to have to measure that. One of the good ways to do it is use a piece of light colored filament, run it down in there till it touches, put a mark on it with a Sharpie, pull it back out, use a yardstick. That'll get you close enough. This one I've measured before because I use it on my other ERCF. It's about 1070 millimeters. So what I'm going to do is I'm going to pull this little piece out. I'm going to run that filament back in so it's not hanging out way too far. Actually, I'm just going to push the servo up and push it in by hand a little bit. And now I'll put my Bowden tube in there. Now we're all hooked up. Now, when you do this, you're not on camera, I would highly suggest you don't have this big weird curve going through here. I would turn this thing around so it faces that way, or has as little curve as possible, and then run your ERCF that way. This will cause problems down the road. But for calibration, we're going to be okay. One thing you'll want to do is go into your MMU config, and I'm going to show you this real quick. Pretty good idea in your parameters. Come down here in this gear max velocity. I've got it at 100. I would suggest don't go over 50, especially if you have a NEMA 14 or you haven't tuned your motor current. 50 is a good place to start so you don't have your extruder and losing steps. And that sounds kind of like a robot blowing a whistle. So back this down. It's at 100 for me. I'm going to leave it there. I know it works, but you should probably start out at 50 and just leave it that way through your calibration. It makes your whole life a whole lot better. Anyway, we come back here to the Happy Hare, and here's our command we're going to put in. My Bowden tube is 1170, so I'm going to put it in here. I want to say, let's do 1125. So the extruder, if you can see here, Bowden tube comes into the extruder, right? When you do this calibration, it's going to shove that filament through there, the amount that you told it to. And then it's going to stop and it's going to pulse. Just move in a little bit at a time until it hits either your extruder switch, if you got that configured, or it runs into the extruder gears. Now, what we don't want to see is we don't want to see that filament come clear through and run right in there before it stops. It's got to stop up here a ways. Yeah, 50 millimeters or so is better, right? You don't want it to come running in here and just hit that before it stops, because it will not get the proper measurement. So if you see the filament come in, zip clear down there and then stop, you're going to have to redo the calibration. It's no big deal. It'll retract it out, but it's not going to get a good measurement. Okay, so it's going to run out through here, come down. We want to make sure that it does not hit that extruder switch before it pauses. So now I'm going to send the command, and we'll see what happens. There we go. It stops there to check the encoder is working. Now it runs that filament clear in through the Bowden tube. There, see that? It went clear in. Now we're going to have a bad calibration. So what we can do is let it go ahead and finish the cycle. And once it tells us kind of what it thinks our Bowden length is, we can adjust it to about 25 millimeters underneath that, because this is another important thing. If you don't get this right, you'll end up grinding gears. You'll end up grinding the filament. You'll have loading and unloading issues. So this is another one where the stack up intolerances is going to get you if you don't calibrate it right. So take your time here. If it doesn't stop before and then pulse its way in, you need to redo it. And it says the Bowden length has been saved. So you can see here, it thinks it's 1127 millimeters. So I'm going to rerun this at 1100. You know what? Let's go 1075. Take 50 millimeters about off. Okay, on our second one, it went through, and this time it thinks it's at 1078. So that's quite a difference from 1127. I think probably the difference here is that my other ERCF has an ERAC on it, ERAC cutter. So the Bowden length is actually going to be a little bit different because of the way it hooks into the encoder. But this time, what I'm going to do is I'm going to say 1025. And I'll rerun it with that. And make sure that it pauses before it hits that extruder switch. And here we go. Yep, there it stopped. Just about that far up. That's about that far above. So we're good there. Now it's going to check that measurement, and it'll be accurate this time. All right. Now we see we've got 107.1.3, 107.1, 107.3.2. So they're all pretty close. Our first one was 1127. We came down here at 1,078, and now it's saying 1,072. So I'm going to say that's pretty good. We saw the correct behavior. It paused before it hit the extruder switch. I'm going to say that's pretty good. If you think there's anything wrong, run it again. You want this thing to be within, I'd say 5 millimeters. If you're less than 1 out between 2 different runs, that's even better. But this is another one that it's another stack up of tolerances. So you want to take your time and get this one done correctly. The next step is calibrating the individual gates. Now, this sets the rotation distance of each gate, because when you put your little BMG gears in there, it may not be exactly centered on the filament path, and that little groove, the filament might right here, right here, might right here, and each, just because of the distance away from center, it can have a little bit of variance. So this is going to calibrate the rotation distance of each gate. It's going to be a pain because you kind of have to load it in from the back. You don't have to go through the buffer and spool it all up. You can just take a piece of filament, shove it in there. Now we're going to home the selector, and I'm going to use clipper screen for this real quick. Home the selector. Select the gate you're calibrating. In this case, gate 1. And then paste in your calibrate gates code and send it. And it's going to clamp down, and it's going to send about 400 millimeters of filament, just like it did on gate 0. Now, we'll let that go through, and it will tell you what the next gate counts are. There, it's done, and it parks the filament back in there. So now you can see here it says the gate 1 rotation distance is 22.538 versus 22.552. And so it will store a ratio between gate 0 and gate 1, and it will store a ratio between gate 0 and whatever other gate you're going to calibrate. You should go through and do all these, otherwise it'll substitute the gate 0, and if it's not right, you'll compound more tolerances. Like we talked about, you'll have problems with over or under extrusion and Bowden loading and all that. So just take your time and do that correctly. And that wraps up the physical calibration of the ERCF. Well, that about sums up the physical configuration of the ERCF. Today, we covered the selector offsets, we set up all the servo arm positions, we calibrated the gear stepper so that it actually pushes out 100 millimeters of filament when we ask it to. We made sure the encoder measures that 100 millimeters very accurately. We set the Bowden length in the Hare software, and we calibrated all of the gates so that they push out an equivalent amount of filament each. I'd like to take this chance to thank Mogi for making Hare software and all the work he puts in. He truly does work hard on this, and it's a great software setup. So thank you, Mogi. I'd also like to thank the ERCF team for making the ERCF what it is today. I really appreciate all the hard work each and every one of you puts in. I hope also that you were able to learn something today. And if you have any questions, you can hit me up in the comments or over on Discord. As always, thank you for watching, and I look forward to regaling you with an inordinate amount of indecipherable and convoluted vernacular post-haste.